In JUnit 5, nested tests are a feature that allows you to group related test methods inside a nested, non-static inner class. This helps organize tests into a more structured and readable hierarchy, which is useful for testing complex components. The main purpose is to provide a clear structure that reflects the relationship between different groups of tests and the test class. This approach is a benefit when you have a class with more than one method and you want to write separate groups of tests for each method. Using a nested class makes the test suite easier to read and understand. By the end of this session, you will learn how to implement a nested test, how to isolate context for test scenarios, and how to manage lifecycle methods. Let's walk through the class members that will be tested in this demo. In the IDE, there are 3 types of class members. It has 3 fields, 1 constructor, and 5 methods. This class is a good candidate for a nested test because the action will change depending on if the user is logged in or logged out. The fields are username, password, and logged in. Username and password store the value as a string. However, logged in is a Boolean flag that tracks if the user is logged in. We see the default value is false. Public user is the constructor. It creates a new user. We must provide a username and password. When creating the user, and the state of each user starts by being logged out. Check password. Logged in. Log out is logged in. And change password are the 5 methods. Check password is a helper method that checks if the provided password attempt matches the user's stored password. It returns true when there is a match. The login method authenticates the user by validating the password with check password. Log out sets the status back to false when logging the user out. The is logged in method returns the current login status. Now, when it comes to change password, it allows the password to be updated, but only if 2 conditions are met. First condition, the user must be logged in. The second condition requires the old password to be correct. That's why you see a message right here that says old password does not match. Now, let's write the nested test by going to the user test class. We declare a field, which is an instance variable for the user test class with private user. It will be available to every test method within this user test class and all of the nested classes. At this point, we managed to set up and we got to manage the tear down method. Let's start by writing at before each for the setup method, followed by public void. Create user is the name of the method. JUnit 5 can discover and run our tests with package private access. So we can skip writing the public access modifier. You can keep public or you can remove public. Remove that underscore. That's surely not needed. Now, either way, the method will be seen by all other classes within the same package. I'm going to start with the body of this method with the print statement. And within the print statement, I'll make sure to make it descriptive. How about I start with something like outer, because it's describing what and where this before each annotation is located. Outer at before each is the name of the annotation, followed by what the setup method will do. It will create user object. On the next line, I'm going to write user equals new user. And within this new user, I'm going to pass in two arguments. The first argument will be the username, which is lambda test user, followed by the password. The password will be initial password. This create user method, with the help of before each annotation, will automatically run before every test method in the user test class and the nested classes. It will initialize the user field by creating a new user object with lambda test user as the username and initial password as the password. For the teardown method, I'm going to write at after each annotation, followed by void as the return type. Clean up user is the name of the method, followed by the curly brackets. Now, I'm going to also write a print statement. And this print statement will also start with outer. Got to spell it right. At after each, followed by what this method will do. It will clean up the user object. Yes. On the next line, I'm going to write user, there you go, equals null. Okay, next is the test annotation for the test method. On the next line, I'm going to write display name. Display name will be descriptive, explaining what this method will do, which is user is created successfully. Return type is void. Name of the method is created brackets. And I'm going to make more room. Now, the purpose of this test is to verify a user object is created and in the expected default state. So those are two things. The user object is created and the default state is got to be correct. Now, let's write assert not null. The red writing indicates we need to make an import. So when I hover assert not null, I'm going to import the static method and make sure to pull in from the package org.JUnit.Jupyter.API. Bingo. Now, on the next line, I'm going to write another assertion statement, but this will be assert false. And within this assertion, I'm going to write a user is logged in. Let's go ahead and add a message. A new user should not be logged in. Okay, so now Let's get started with how to implement a nested test. You create nested tests by annotating a non-static inner class with the nested annotation. Each inner class can contain its own set of test method, test annotation before each annotation and after each annotation. Here's a list for a nested test. The first characteristic is the nested annotation. It is required to signal to JUnit that the inner class contains test scenarios. The second characteristic is the inner class. It is a class that contains the nested tests and needs to be a non-static inner class. This allows the inner class to share the state of the outer test class instance. Let's go back to the IDE. So we can create a nested annotation. And we create a nested annotation by simply writing @ which is short for iterate nested. The purpose of this annotation is to group related test scenarios together in a nested class. It helps to organize the test suite. At display name, what will I write? How about I write when newly created. Display name allows us to provide a descriptive name for our test. The next step is to create our first inner class called WhenNew. Let's create one more inner class, but we must start with @nested @display name. This will be, how about I say WhenLoggedIn. When it comes to display name, it is not required. However, it is good for reports and to help understand what is being tested. The second inner class will be called WhenLoggedIn. At this point, we have two nested classes inside of this user test class. Next is to isolate context for test scenarios. That means each test will run independently and will not influence other test scenarios. This prevents a failing test from causing another test to fail. There are three concepts for isolating context for different test scenarios. First, you isolate the nested class. That was processed when implementing the first inner class and second inner class. The second concept improves reliability with each test. It clarifies the test condition and leads to consistent test results. The third concept enhances an understanding of each test so it is easy to maintain. In the IDE, let me show you, for starters, the outer each and after each, how they isolate every test scenario. Before each, it creates a new user object before each test, and after each, sets the object to null when the test is finished, so data from one test does not impact another test. Now, let's write our test inside the first inner class, WhenNew. We do that by making room, and I write @test, which is the annotation for the test method, followed by @display name. Can log in with the correct password. Void can log in. Recall from the create user method, the correct password is initial password. Let me go back to the create user method, which is in the setup. The correct password is initial password. I'm going to copy that information and I'm going to use it for this here can login. So therefore the body for can login will be user.login and pass in the initial password. The method login is coming from our user class, which has a parameter of password attempt. Let me go back to this here. Initial password is the argument. Assert true. User.isLoggedIn. We call isLoggedIn also from the user class. The can login method verifies if a newly created user can successfully log in with the correct password. User.login simulates a user making an attempt to log in. Assert true checks if the user status is now logged in. The test should pass if the assertion returns true. Our next test. All right, go. I see the IDE had 2 lines where the cursor was located. So the next test is going to verify if the wrong password prevents a user from logging in. At display name, cannot log in with an incorrect password. Return type is void. And I'm going to name this method cannot log in with incorrect password. The user object calls log in, then pass in wrong password as an argument. Assert false, we have user.isLoggedIn. So that's 2 tests. I'm going to write one more test for this inner class. At test, at display name. Let me bring this up some more. Bingo. And inside this at display name, I'm going to write cannot log in with, and no, that was already, this here would be cannot change a password because I just did cannot log in with an incorrect password. This here, yeah, it's going to be about changing the password. So for that, I'm going to say cannot change password. Return type is void. Cannot change password is the name of the method. And inside this method, it's going to be assert throws, which will be used to test for an expected condition. It's going to tell JUnit 5 to expect an illegal state exception to be thrown. Make sure to include .class and add the comma. Now we write the lambda expression that will execute the action, which is an attempt to change the password. The lambda expression starts with parentheses, followed by a hyphen, then an arrow. And I'm going to put the brackets. Inside the curly braces, we write user.change password. The old password is initial password. And the new password is new password. At the end, I'm going to write a semicolon. Yes. That's it for the last test. To sum up this method, the user object is a new and not logged in. So it's going to be a new user object, but it's not logged in. Therefore, it makes an attempt to change the password, but should throw an illegal state exception because the user must be logged in to change the password. Let me go to the change password method. We see it shows those two conditions. It throws the illegal state exception. User must be logged in to change password. The test should pass if this exception is thrown. Let's run. So I'm going back to the class level and run. In the run window, we see the outer class test. Outer test. User is created successfully has a green check mark. For the nested class, WhenNew created, it shows each test can log in with the correct password, cannot change password, and cannot log in with an incorrect password, also pass with the green check mark. Next is to manage the lifecycle methods. Recall from implementing a nested test, I mentioned two characteristics. The two characteristics were nested annotation and inner class. Now, however, lifecycle methods is the third characteristic. We cannot use the before all or after all configuration annotations. They cannot be implemented because by default, an inner class cannot contain a static member. Before all and after all are static. However, before each and after each are not static. So we can implement those two configurations. Let me show you by going back to the IDE. Inside the class, I will write before all, void, name of the method will be, how about login user? Now, notice how there is a red line under login user. That lets us know we have a problem. When I hover the method, yes, and it says method login user annotated with before all should be static. We fixed this problem by replacing before all with before each. And now the red line goes away. The same problem would happen if we tried to implement after all. For example, I'm going to make more room. Then write after all. The name of this method will be void log out user. We see the red line again. This time I'm going to hover and watch the message, the error says. Method log out user annotated with after all should be static. Change after all to after each, and it'll take care of it. A method for before all or after all must be static because by default, JUnit creates a new instance of the test class for each test method. However, the method before each or after each do not need to be static because they are designed to run on the specific instance of the test class that is created for each test method. Let's finish the login user method by writing a print statement. Inside the print statement, I'm going to write enter at before each. Login user. On the next line, I'm going to write user.login. And pass in the argument that says initial password. Yes. Okay, so for logout user, how about we start with a print statement like we done with the other methods? And for that, I'm going to write enter. And the reason why I'm writing enter, because it is inside the inner class. We have one for the outer class. So for these two, they're inner. Enter after each. How about just say something simple like login user out? For this, I'm going to write a condition. And the condition is going to start with an if statement. This says user does not equal null and user dot is logged in. Inside the if condition, I'm going to write user dot log out. The lifecycle methods of the outer class are executed around the lifecycle methods of the nested class. For example, the outer before each annotation executes before the inner before each annotation. Nested test classes inherit the before each and after each methods from their parent class. This allows you to build up context. For instance, the WhenLoggedIn class, I'm trying to go to it. The WhenLoggedIn class is this, the WhenNew right here. The WhenLoggedIn class benefits from the create user setup method in the outer class, and then adds its own setup for login user. Now, it's the same for the logout user. Same thing happens because there is a complete test isolation benefit because the code has two levels. Process with the outer each after each method cleanup and an inner after each method logout user. So it has two level cleanups, and that's the benefit because they have two levels. Now, when it comes to the next part, I'm going to create now the test methods because inside this WhenLoggedIn, we have the before each and after each. And I'm going to create 3 tests because if we think about it, the outer part has 1 test. But for the inner, I'm going to create 3 tests. So let's start by writing the test annotation. Display name will explain what will be tested, and this can be logged out. Void is the return type. Can log out is the name of the method. Assert true will be the assertion. User is logged in. Yes. Now, the next line will say user.logout. and one more assertion for assert false. And this is user.isLoggedIn. Assert true verifies the precondition to confirm the user is logged in. User.logout verifies the status changed from log in to log out. The outcome is verified by assert false to check if the user is logged in. Method returns false. Next, test is going to have display name. Let me go ahead and explain what this here is. This here will check that you can change the password with correct old password. Return type is void. The method is can change password. The purpose of this first statement for can change password method is to replace the initial password with the new password by writing user.change password. Pass in initial password as an old password. The new password, how about I write new password? Next two statements are to log out, then log in with the new password. Therefore, on the next line, I'm going to write user dot log out. The last statement is to verify the user is logged in. So I'm going to put an assertion. Assert true, user dot is logged in. Last test. Display name. And for this here, I'm going to write cannot change password with incorrect old password. Void. Cannot change password with incorrect old password. Bingo. I know it's long, but it's very descriptive. Assert throws. Okay, now inside assert throws, we're going to have illegal argument exception dot class. And after class, write the comma. And at this point is when we write the lambda expression. Started with the parenthesis, hyphen, and an arrow, followed by the curly braces. Inside the curly braces, we write user dot change password. The first argument, incorrect password. The second argument, new password. That's it. Now, let's run. Okay, so at this point, there are some errors. Let's fix the errors. So I see it failed at this here, line 86, because I see the yellow line. So let's check and see why it failed. There's a step missing in the can change password method. After log out, should say user.login. And the name of the argument is new password. Now, Let's run again. This time it passed. We see all test scenarios in the run window with a green check mark. If you want to see a test fail, even though we just saw it a moment ago, let me change some things up to show you how we can make it fail. In the same method, just use it since we just added this here part. To make it fail, I'm going to change initial password to new password. And for the user.login, I'm going to change that. How about I change that to just say password? So now we're passing in values that are not correct. This time when I run, we see the run window show a failure for when logged in the can change password with correct old password method. Okay, so let me go back and put it how it's supposed to be. And I'm going to run again just so it can just show green, because seeing two failures, I'm going to run it again just to make it show all green. As expected, each test has a green check mark. To recap, the agenda was to implement a nested test, isolate context for test scenarios, and to manage lifecycle methods. A nested test in JUnit 5 helps to group and organize our test scenarios. We can provide a structure for each test, improve clarity with each test while enhancing maintenance with each test. Let's go back to the IDE right quick to go ahead and recap one more time. Now, the key feature is the nested annotation. And we have two of those because we have two inner classes, WhenLoggedIn and WhenNew have the nested annotation. This nested annotation allows you to create test groups. A nested test is powerful because each test inherits the setup before each method and tear down after each method from the outer class. They provide a baseline to create a user before each test and clean up a user after each test. The inner classes, WhenNew and WhenLoggedIn, are like each other. However, the difference is the WhenLoggedIn class has its own life cycle methods before each and after each. So we see here WhenNew and WhenLoggedIn. Let me show you the difference, just to talk about it one more time in the recap. WhenLoggedIn have before each and after each. Here is the execution order. First is before each from the outer class to create a new user. Second is before each to log in a user. Next is the test method. After the test method, then the inner class after each method will log out the user. Finally is the outer class after each will clean up the user by destroying the user object. That's it for nested tests in JUnit 5. If you would like to learn more, then make sure to follow the blogs at https://www.lambdatest.com/blog and community.lambdatest.com. In addition to the blogs, you can earn a certification at www.lambdatest.com/certifications. Get educated, get recognized.